Hello, everyone. Good afternoon. My name is João Biel. I teach in the Department of Anthropology and also at the Woodrow Wilson School. And I'm a co-director of the Brazil Lab, Luso-Afro-Brazilian Studies, together with a colleague and dear friend, Pedro Meira Monteiro, who is the chair of the Department of Spanish and Portuguese. It's a great, great pleasure to welcome you to our second Brazil Lab colloquium this fall and ever, since we just launched the lab a few weeks ago with a wonderful event bringing Arminio Fraga and Angela Alonso to discuss the future of Brazil, something very, very pressing, right? And so we are delighted to have a wonderful speaker today and a discussant, from the Princeton Environmental Institute. But before I introduce our speaker and discussant, I just want to call your attention to another event that's taking place tomorrow, Amazonia Inc., Amazonia Incorporated, which is a film by Estevão Chavata and Beto Verissimo, the environmentalist, social entrepreneur who is with us here today. He will be with us tomorrow. And Beto is actually a character in the film, which is an incredible story about a riverbank and indigenous communities coming together to demarcate their land against the backdrop of wild big capital in Brazil. So we don't know who the anonymous society is, in Portuguese you say SCA for Inc., which is anonymous society. So initially the idea was, let's Brazilians get to know the anonymous societies of the Amazon, but in this case, the organized crime and logging and mining, might well stand for the anonymous society that needs to be brought, if not to justice, at least to the table to discuss, the future of the Amazon, its people, and the planet. So we'll have a wonderful event tomorrow, Amazonia Inc., and the incredible artist Fazal Sheikh will be a discussant together with Eduardo Cadaver, a professor in the English department. On Friday, an incredible event organized by our wonderful graduate students from Spanish and Portuguese, Marina Bendran and Jonathan Aguirre, with the great support of Princeton Environmental Institute, the program in Latin American Studies, and the Department of Spanish and Portuguese and Anthropology, all co-sponsors of today's event. And I just mentioned Fazal. It's great to have Fazal here. Thank you for joining us today. And Gabriela Nozales, who is the director of PLAS, who is also supporting the event today. So, all this said, please feel free, to look at the posters around the table and join the events tomorrow afternoon and Friday the whole day. Tomorrow's event is at Bowl 1 at the Woodrow Wilson School at 4:30, and Friday's conference is room 10 in East Pine. And we have some stickers, that we hope you will pick up, put on your cell phone, take with you of the Brazil Lab with the beautiful imagery that the one-of-a-kind Lula Rocha, a Brazilian designer, created for the lab based on the flower and seed of pau-brasil, the tree, the extinguished tree, which was the first, extractivist prize of Brazil, that's kind of resurrected in a possibility of something new moving forward.
The only country named after a tree.
The only country named after a tree, Brazil from Pau, Brasilia. Tasso Azevedo is a remarkable environmental engineer and an innovative doer in the field of forest and land use, sustainability, and climate change. He coordinates the CIEG network, a system to estimate green gas emissions, as well as the one-of-a-kind map Biomas, a platform to produce annual land cover and land use country maps through a multi-institutional collaboration between ecologists and remote sensing and computer science experts. A SCOL fellow, Tasso writes for Brazil's major media outlets. He has also played a key role in the design and implementation of the Brazilian National Plan to combat deforestation and the Amazon Fund, the world's largest forest protection funds. In Tasso's work, the environmental sciences and the humanities blend with a deep commitment to meaningful, future-oriented public action. It's a great pleasure to have you with us. Mike Celia, known to many of us on campus, is the Theodora Shelton Pitney Professor of Environmental Studies at Princeton, where he serves as the director of the Princeton Environmental Institute. He is also a professor in the Department of Civil and environmental engineering. It has been a great pleasure getting to know Mike Celia in the past few months and share our excitement with finding ways to make the Brazil lab an important nexus to discussions about the environment on campus, in academia, and beyond. He is the recipient of multiple national and international honors. Mike's areas of research include groundwater hydrology, multi-phase flow in porous media, numerical modeling, things that we all understand very little about, but are eager to learn how it applies to the pressing issue of planetary survival, and subsurface energy systems with a focus on the geological sequestration or carbon and shale gas systems. So we want to give Tasso our warmest welcome to Princeton, and Mike, thank you so much for being with us today.
Cool. So I will talk about three things. One, something about this last report from IPCC from last Monday. Just like three things you need to know. All the rest is too complicated for me to understand, to actually talk to you. So I'll just say, a few words about that and connect this to the importance of forests to tackle the problem of climate change, and then where Brazil fits on that. And then this will be kind of an introduction to explain why we are doing all those maps of Brazil and stuff. And I will talk a little bit about this project that we run on mapping and understanding the land use change that happening in Brazil, and with some insights that we can get from this current work that we are doing. And then we open for questions and discussions and so on. So I will not talk about the politics during the presentation, but hopefully there will be questions afterwards and we can address that. Okay, so we have this Paris Agreement from 2015, and in a nutshell, it's an effort to guarantee that we stay well below, that's very important, well below the 2 degrees Celsius in increase over the temperature comparing to the pre-industrial levels. And more than that, to pursue efforts to have this limit in 1.5 degrees, not just 2 degrees, below 2 degrees, but 1.5 degrees. So because of that, and that was pretty new in 2015, there was a request for the IPCC, the Intergovernmental Panel on Climate Change, which is kind of a group of scientists that works under the United Nations umbrella, to evaluate whether this is possible. Is it possible to get to the limit to 1.5 degrees? And so they worked for 3 years, and they just launched the report last Monday. Basically, it starts like this. It's pretty depressing. That's how much we have increased already on the temperature. Is 1 degree, or less in 2017. And we are basically, even with all the efforts from today, we are just running up. And then somewhere between 2030, 2045, we would cross the line of 1.5 degrees. And by 2050, 2060, we will cross the line for 2 degrees. So we're not doing the sufficient. This is bad. Yes, this is pretty bad. So that's another graph from this report. But basically, reading this is purple is very bad, and yellow is not so bad, but bad. That basically was happening. So purple means like the risk is immense. It's things that will be irreversible and will be persistent over the time. So that's basically what says purple here. So here's where we are, like 1 degree, and here is 1.5 and 2 degrees. So, for example, threatening, unique systems and ecosystems, we have impact today, and that will be very bad impacts in 2 degrees and so on. But the important thing to see here is that 1.5 is less worst than 2 degrees. That was the message that the IPCC wants to show. Say, really, if we do an effort to stay below 1.5, we are talking about less impact than 2 degrees. And it goes all the way to tons of things like, say, crop yields, flooding. Here is the corals. Corals is gone. Like, we're seeing the effects now, and by 1.5 degrees, it's over. Yeah, and so on. So you have a lot of information on this. The big message here is, yes, it makes sense to try the 1.5 is important because the impact on 2 degrees is much higher than 1.5. Now, if we have to do that, how much greenhouse gas we still can emit? What's our budget of emissions in order to have a chance to stay on 1.5 or 2 degrees? And that's, there is like 50 pages explaining this, and then you can extract these 4 numbers, which is to be, more simple. So it's basically, if you want to limit it in 1.5 degrees, if you want to have 50% chance to stay here, then our budget is 770 gigatons CO2 equivalent. And just to put a perspective on numbers, what is 1 ton of carbon? 1 ton of carbon is how much one car, like running 20 kilometers a day on gasoline, will emit in 1 year. 1 ton, simple as that. Or a cow, a beef cow, 50 kilograms of methane per year, roughly equivalent to 1 ton of carbon. So one animal, 1 year, one car, 1 year, 1 ton. So 770 gigatons is a lot of tons, like it's billions, 770 billion tons. But as we will see, we emit a lot every year. But that's to have a perspective what we're talking numbers here. And if it's 2 degrees, for example, to have 50% chance, 1,690 gigatons, and so on. Normally, I don't like to get airplanes that have this chance to fall. So I would rather get the airplanes here, right? 2/3 of chance to get there, or something like that. So, but if you go to 2/3 of chance, then it's the budget's low, it's smaller, right? For the sake of the examples that I will give afterwards, we are staying here on the 50% chance of 1.5 degrees Celsius. So what IPCC did was they studied a lot of scenarios that were put out by different research institutions all over the world on top scientists everywhere. And basically each one of those lines is one of those studies, trying to picture different actions that you can do and what will be the consequence on the emissions, and then create a trend line that will be within those 770 gigatons in aggregate on the period. What we see here, 2 things to remember. This is 0, right? 0. And this is the annual emission during the years. What you see here is all the scenarios, all of them, at a certain point during this century, the emissions should be negative. How an emission could be negative? It's like that you have emissions and you have also the removals. So the removals would have to be higher than the emissions at a certain point on this century. So it's a huge effort. It's not just like decrease the emissions, but you also have to suck a lot of this carbon from the atmosphere, right? Yeah. So it's just to have an idea that is, if you start to decrease later, let's say on this gray side, you have to go deeper on the negative emissions. Simple, right? So it's like to have this perspective efforts. If we start earlier, the effort is still very big effort, but less effort. Okay, so that's how much we emit today. 52 gigatons, 52 billion tons. It's like if we have 52 billion cars running, and we don't have that. We have 2 billion cars, not 52. But we have cars, we have the thermal power plants, we have the deforestation, we have tons of things happening that have a lot of emissions, right? That's where we are heading to with all the commitments on Paris Agreement, with all the efforts that have been done in China, in Brazil, in US, in other places. That's where we are heading to. So we are going to increase our emissions up to 2030 instead of decrease. That's where, hopefully, we should be in 2030, and that's where we should be by mid-century if we want to get into the 770 gigatons budget for the whole century, right? So it's a huge transformation that we need. So the way to do it, basically, in all those scenarios, there is those four formats. And it's to simplify is, what is in gray here is the emissions from everything but land use, deforestation, agriculture, stuff like that. So, and what is in, I don't know what color is this one, but brownish something. This is like land use, agriculture, forestry, and so on. And this one, the yellow thing, is actions to remove carbon from the atmosphere using other technologies apart from growing trees and things like that, like capture and storage the carbon in the ground, in gas. Well, there is tons of technologies in this study. Those technologies are not really well known in large scale, never experienced in large scale. We don't know what could happen. Maybe we can have some explanation about that later on. But there's no explanation. And the IPCC report says, look, this is very complicated. We have to put on the scenarios, but it's very complicated because we don't know exactly how to do this in large scale. But we know how to do this other part. That we know how to do. We know how to cultivate. We know how to grow trees and et cetera, et cetera. So we want to play in these fields here, which is decrease strongly the emissions, and then stop to have emissions by deforestation and other practices, and have more practices that actually capture more carbon. So then we can see a little bit of the role of the forests. So this is the amount of carbon that we have, equivalent in carbon, that we have on all the fossil fuels that are available to be extracted, as we know the references today. Okay, it's about 2,700 gigatons equivalent in the ground. So much more than what we can emit, right? But it's here. And that's how much we have stored on forests. So we have more carbon stored on the forests than in all fossil fuel reserves that we have available. So the way it works today is that we are burning this fossil fuel, taking this to the ground, to the atmosphere, and this is about 34.5 gigatons of CO2. The number 50, something that I said before, include other gases. I'm just talking about carbon now. But also in the forests, we have emissions. Not just forests, but land use in general, in terms of carbon. It's like chains on the land use. So for example, if you have a pasture, and then you have an orange plantation afterwards, then it captures carbon. Because the orange plantation has more carbon in the plants than the pasture. So it's a way, for example, to gain. The opposite direction would be like an emission of carbon, right? But most of that, this is deforestation. So it's 4.8 gigatons that we are emitting from deforestation. But the forests have an immense service, which is like they capture every year tons of carbon from the atmosphere. So we emit like 34 plus 4.8, but the nature, the planet is actually capturing, sucking this carbon again on a level that was possible in the past to balance what we were emitting. But today we are emitting much more than the nature can capture again, being forests and being the ocean. The ocean also sucks a lot of carbon. So what we need to do is to decrease the emissions here, more electric, renewable energies, electrify the transportation and so on. So we want to decrease here as much as possible, stop deforestation on anything that creates emissions here, and increase the capture by reforestation, regeneration, letting increase the content of carbon in the soils by the type of management you make in the soils and so on. So that's the absolute importance that we have on forests to tackle those climate change. Now, where Brazil is on that? 13% of the forests in the world are in Brazil. But since the forest in the tropics has much more carbon than the forests in the temperate zone, which are most of the forests in the world, 3/4 of the forests in the world are in temperate zone, 25% of the carbon actually is in Brazil. 25% of the carbon on forests is in Brazil. But we have the highest rate of deforestation. So as a result, Brazil is one of the largest emitters of greenhouse gas emissions. Like, despite of being one of the most renewable energy, champions, we have a lot of emissions basically because we are burning down forests. So we make like 3 to 5% of the global emissions, 6 or 7 largest emitter, depends if you consider European Union as a group or separate. But we are top 3 in terms of carbon sink, probably the first or the second in terms of carbon sink. About 10% of all this terrestrial carbon sink is happening in Brazil. The problem is, every time I lose forest here, I decrease also the sink. So it's kind of, it's not just I have more emissions, that I have less capture, because I'm decreasing the area of forest. So Brazil is absolutely crucial. There is no way we will solve this problem of climate if we don't take care of our forests properly and land use in general. So let's repeat it. So we know that by far, and this comes from the studies that we do annually on estimating the greenhouse gas emissions in Brazil, that our main source of emissions is actually land use change and land use. This is the green part of the graphic. You will notice that actually there was a big decrease of those emissions from 2004, 5 to 2010, 11. That's mainly due to the decrease of deforestation in the Amazon during this period. There is a lot of work to explain this and what happened. There is a TED talk that I did recently that was basically about that. So I'm not getting to that, but basically is that's our main source of emission. Even after we decrease a lot the emissions and the deforestation in the Amazon, still 70% of our emissions come from this area. The interesting is, in Brazil, we are very good, and we have a lot of experience for many years, pioneering since the 80s, to measure what happens in one of those transitions, which is basically from forests to non-forests. So we know how to measure that and show, okay, we had forests, now we don't have forests. What we don't know is what happened afterwards. So after you clean up the forest, it becomes a pasture. It come back to a forest there. It's an agroforest, it's a forest plantation. It moved from logging to agriculture or mining. Or what happened? What happened with the land? What's happening? What's the dynamics? What is causing the change that we have happening? So we want to understand, and that was the challenge that we started digging in 3 years ago. We want to move from understanding the change just by forest, non-forest, or trees, non-trees, to something more complex, of knowing any one of the transitions and understanding what's happening in any one of those boxes here, from forest to crops, forest to urban, things like that. So, so we started this project called Map Biomas, which is a collaborative effort with a lot of institutions, including universities, tech companies, and NGOs, think tanks, to kind of understand what has happened in the last 30 years in the land in Brazil, the whole territory. So the challenge was, let's make one map that represents Brazil for each one of the years since the 85 and produce this as a time series, and then we can compare any pair of years and understand what's going on the territory, kind of a telefilm. So in a nutshell, the project is take every pixel from Landsat imagery, which is a 30 by 30 meter resolution, so it's a square of 30 by 30 meter. There is 9 billion squares of those in Brazil. So we take each one of those squares and try to explain what happened from 85 all the way to 2017, year by year, in each one of those squares. So that's the project. So we process everything pixel by pixel, and we use everything on the cloud. Everything we process using machine learning techniques and so on. It's for another day how we do it, but believe it, it works. The first maps were crap back in 2015, but the idea was learning how to do it. And we make those collections about 10, 12 times. And finally now in last August, we launched the final collection, which we call Collection 3, which have basically one map for Brazil for each one of the years from 85 to 2017. It's an open platform. What you see when you open the platform is something like this. You can navigate over the time. You can navigate by zooming in all the way to the pixel. And you can also move in the space, right? So that's how it works. So here is like all the classes. So you have like different types of forests, non-forest natural environments, like you have the mangroves, beach, water, river, agriculture, pasture, all those classes. You can, you can turn on, off the different classes. And everything you see on the maps, you see the statistics, the historical statistics, and also the year that you are on the right side. So let's say I take an example here. I'm just zooming in here at Xingu area, which Patricia knows a lot. So that's the Xingu area. This is an indigenous reserve here, the Parque Xingu, no? The Xingu Park. And that's the picture in 85, right? Some agriculture here. This is like the pink is agriculture. This yellow is pasture. Yellow, almost white. This is like grasslands, natural grasslands. This would be like open forests, the light green. That's dense forest, obviously water in blue. And that's, let's move now to the year 2000. So this past 15 years. So deforestation is growing up here, basically for pasture. The agriculture is going up. Remember, it was down here. Now it's moving toward this direction. Here is Sinop, for example. And then this is 2017. Basically, agriculture everywhere. Agriculture here means basically soybean in this case. Some cotton, also some corn, but mainly soybean. So what you see here is basically the only place where there's no intrusion of the agriculture and conversion is basically the indigenous reserve, which shows like the immense importance that you have on indigenous lands, lands that are occupied by communities, and as well as the protected areas, right? But you can see this, have a look on the history. Now, apart from seeing this for all over Brazil, you can also navigate on the states and on the municipalities, like 5,000 municipalities in Brazil. So you can go to each municipality and understand those dynamics for each municipality and so on. So I will take just one example, and that's Sinop. So I'll go to this region here. So this is like the municipality of Sinop. I go closer. And that's Sinop in 85, right? Very remote. There was some agriculture, some forestry, some things are starting to open. That's the colonization that starts during the military government. So the 85 is like the last year of the military government in Brazil. Oh, well, I would make a comment that I would not do. Maybe we have another military government. So yeah, so this is 2017. So it's kind of, this is 85, 30 years later. That's basically agriculture. In this case, again, soybean. Pasture moved to this area. This is like a small landowners, settlements, and etc. And so the other thing you can see here the trends, like forest is going down, agriculture is going up. Pasture is kind of a more stable along the time, because it's normally what happens that pasture grows over the forest, and then agriculture goes over the pasture. Pasture goes over the forest, and that continues to go on. The thing here is that you can. There is a tool here in which you can click their transitions, and then you can turn this map into something that compares two dates. So in this case, oops, this case, we are comparing 85 and 2017. So we basically took two maps, put one over the other, see all the difference that we have, and then we paint, here is painted in green. There is some green here, you can't see, but there is some green here, which is like positive transitions, like things that were not forests or natural environments, and now is natural. There is some of them.
Yeah, it's covered in
There's
green.
there's some. Right? And then it is basically red, which is the opposite, right? It's loss of natural environments for something that is like human-made, right? So if you click here on the platform, then you can see that on numbers from what to what. So in the left side is how it was in 85 and what is in 2017. So for example, this is the part that was forest in 85 and now is agriculture. This part was forest and now is pasture, right? And if you click on any of those areas, you can see the area in number, but you can also come back to the map and see where are those areas. So this is a map of areas that were forests in 85 and now are agriculture, mainly soybean in Sinop. And you can add to that the layer with all the properties. So fundamentally, that's something that didn't exist. Like, all information was possible to join, but basically what the platform is showing is property by property, what happened in the property. Now, this was 85 to 2017, right? And then you can also add the image behind. So if you don't trust, there was many people that don't believe on maps. They want to see the image. So you can put an image behind, and then you can see, like, you have this slider. And then this is like 85, that's the satellite image, and that's 2017. So that's the real thing, right? And then you can paint showing, where are the transitions. Now, in Brazil, one application, for example, in Brazil, there is this agreement by the soybean sector, the industry in soybean. They say, we will not buy soy from areas that were forests from 2008 backwards. So if it was, in 2008 was forest, doesn't matter what happens, we will not buy soybean that comes from this area, even if the deforestation don't happen because of the soybean directly. So that was an excellent agreement. It happens in 2007, 2008. So now, okay, so what happened if we compare 2008 and 2017, right? So we can do it. So you could go there, and then you compare 2008 with 2017, and guess what? That's interesting, right? It's much less area that have converted. First, because a lot of the conversion happens before 2008. But you can see that there are areas that were converted in 2008. And then you can see here where are, there are like 2,354 hectares that were converted between 2008 and 2015. You can click here, you can show there in the map, and then you can give to the industry and say, well, you should not be buying from those guys, right? I'm sure you're not buying from them, right? Because they have the deforestation. So it's one potential application of this. And that's the example. That's the real case. Like, this property had a deforestation after 2008, and that's for soybean production, should be excluded for any buying. I will just give another example and then stop with the platform. That's an interesting one I did after our conversation yesterday. This one is like, you can see all the data of this platform also by watershed. The big watersheds, like level 1, let's say the big areas, also the small ones, like the 84 small watersheds in Brazil. So I'm taking like big regions. This is the São Francisco region. It's immensely important. That's where we have this big project to make the transposition, you say? I don't know. Take water from one river to put in another river, channels and etc. It's a massive project that we have here. So São Francisco is a very, very, very key important watershed. So here's the image of the map, actually, from 85, and here is 2017. So I'll just call your attention for some things. This is an area of plateaus, I don't know, highlands, that was basically had no agriculture, that was basically grasslands, natural grasslands. And now it's basically everything is covered on soy. And then you come to the left side, and then here is the growth of agriculture in this area. And there is another growth of agriculture in this area. But the most important is, I don't know if you notice, this is the biggest lake, man-made lake in Brazil. Sobradinho is huge. It's like hundreds of kilometers long and so on. So you see, like, it's decreased the size of the lake. So if you look at this image, this is like the 85 on a close-up. And then you see there's very few agriculture here. The lake's around here, and that's 2017. This is like 25, 30 kilometers, this distance. That's how much the lake moved, right? This is all irrigated agriculture here, and a lot of irrigated agriculture here. It's basically sucking the water. So together with the droughts of the climate change and etc., and we are talking about 30 years. It's very fast. It's really very fast. You can see the same thing happens in Las Vegas. If you take the lake, I don't know the name of the lake, just at the side of Las Vegas, you see Las Vegas growing and the lake decreasing in size. Process like that happen in many places. So here you can see this point out in orange is all the areas that lost water surface during this period, right? Yeah, that's just to show that you can actually make analyses and read all the data. This was done for seeing journalists and people that don't understand about remote sensing, etc., that just be able to work with this data for different purpose. So you can see the data for all those different cuts. So you can analyze rural settlements, Afro-Brazilian territories, the transportation energy infrastructure, watersheds, indigenous. For each indigenous area in Brazil, you can see this analysis, or for protected areas and so on. It's all available. So for example, if some of you working here in topology wants to make this comparison, for example, what's the history of forests inside the indigenous areas and compare with the whole Brazil or the rest of Brazil, you will see immense differences that explain the value of them. So it's just one example, right? So we are producing a lot of materials, which is kind of a more visual, etc. Just some insights of what you can get from those maps. For example, Brazil lost 71 million hectares of forest and natural vegetation in this last 30 years. This is like German plus half Poland in just this 30 years. And that's net loss. So that's like the loss and discount what growth in this period, right? The natural vegetation and forest is still cover 68% of Brazil, which is kind of impressive. 68% of Brazil is still forest or natural vegetation. But if you consider only the forests and the natural vegetation that were natural vegetation forests back in 85, means that it didn't change and was forest, that's 50%. So see the difference. It don't tell a lot about the quality of the forest, etc. It tells that we are actually cutting down forests for them to grow again. What's like, this makes no sense, right? We should be using better the land that is being harvested, being cut already. Yeah, not talk about this. All the material that we produce is public, open. All the collections, the statistics is all open to download, to work as a platform. It's all prepared to process also in the cloud. So if you don't want to download anything, it's 100 terabytes of data. We don't recommend to download. We recommend that you actually work on the cloud. And then we provide source codes and etc. for anyone that wants to work with the data. So everything it's open, the material, all the methodologies is explained. But one thing that, and I'll finish with this, 'cause I think it's running time, right? Is the following. This is a work on a network. It's like there's no one institution that takes care of that. It's basically a lot of people from different institutions working together. So the way we work is that we have specialists on the biomes and the thematic areas that we have, working with people that is very good on code, on develop the structure of the way we will process the image and produce the material. So they make all the source code and etc. Once we are satisfied with this, then we prepare what we call a workspace. And this workspace is a software which runs everything on the cloud. We use the Google Earth engine, which is a very powerful cloud. That's the same infrastructure that runs Google Earth, Waze, and Google Maps. So what they do is they open a window so you can program and code inside the infrastructure. So you use their infrastructure, it's free, and you can do all the work there. And once we have this program, then we can have tons of people, analysts, working on different offices in Brazil, anywhere, like from the most poor university in Bahia to the highest, office that we have in São Paulo, exactly with the same capacity. The only thing they need is an internet connection. And I think it's very powerful and important because it's a way to actually make many people to work with the top of the technology, just through collaboration and through using the cloud computer and so on. Because we structure in this way, this allows us to multiply the work because we don't have to do it in other places. So there is another network that has been formed in the Chaco, which is Argentina, Paraguay, and Bolivia. So they are finalizing their first collection of data, of maps for now in November. There is another group working in all the other Amazon countries, and they will deliver the first collection by December, first weeks of January. There's another group. And obviously we are trying to guarantee that by 2020 we have all the countries in Latin America involved, always with local groups. So we help them to organize themselves, provide the training, the softwares, and etc. They start to develop themselves, and then you have like the thing running. Hopefully we can go to other regions. That's part of the team. A lot of young people. Like this is like where things happen. And the minds of these 20-something people. And that's it.
Thank you.
Well, that's an impossible act to follow. I want to start by just commenting that this is really fantastic work. If you don't appreciate how hard it is to do what Tasso just told us about, just dive into it for a little bit, and the number of parts and the number of people involved, it winds up producing an amazing product that has so much potential that we could spend the next hour just sitting here talking about how we might use this in creative and impactful ways. But I want to take a step back and first, on behalf of PEI, since I also represent the Environmental Institute here, just thanks Brazil Lab in particular. I'm so excited that we're developing what I think is going to be a great partnership, and because we have so much common interest in these kinds of problems. I don't want to take more than just a few minutes, but I wanted to just make two comments and then ask maybe one or two questions and then open it up for discussion, which I think is the interesting part. First, a few comments on climate change, because that was raised here at the beginning of the talk. It's one of the things we spend a lot of time in the Environmental Institute trying to understand, the importance of these natural sinks and how they might evolve under changing climate. Can we continue to count on these trees taking up 25 or 30% of our emissions? Or are there scenarios under which they stop doing that, in which case then we have a very serious problem, okay? And you can ask similar questions in the oceans. I did want to, I just leave that out there as something that's important. I wanted to say something about the Paris agreements. In case you don't know, this of course was a major achievement. You start off talking about the Paris agreements with below 2 degrees as the aspirational target and 1.5 even where we might think about going. All of the commitments that were made at the Paris Agreement, which included all countries at the time, now it's all countries minus one, but if you look at those commitments, we're still well above 2 degrees in terms of the temperature change. So we need to be more aggressive than we already are just to get to 2 degrees. When I look at the 1.5 degree scenarios, I just wanted to say 2 quick things. First of all, not to sound really pessimistic, but my takeaway is we're not going to get to 1.5 degrees because we need this kind of remarkable 50% decrease in emissions over the next decade. And when I look at the practical and political landscape across the globe, it's hard to see where that's going to happen. So instead of saying, hey, we really need to do this, for me the takeaway message is that it's probably not going to happen. We need to accept it as a straightforward fact and then decide what comes next. All right? The second thing I wanted to mention, just all these negative emissions, if you remember that graph, right, it sort of went down quickly and then went below zero. Tasso made a point of this. The BECCS, that's this thing people call BECS. I wanted to point out that the BE part of that is bioenergy. That means stuff that would come from trees and things like that. So the negative emissions part, as it's envisioned today, the CCS is carbon capture and storage. That's something I know about, but I'm not going to tell you about unless you're interested. But because this is about forests, I wanted to point out the BE. The B is bio. And if you're going to talk about taking 10 gigatons or more out of the Earth system, right, out of the atmosphere on an annual basis, the impact on forests and all vegetation on the planet is absolutely enormous. Okay, so I don't think that is feasible or realistic, even though it's needed right, to get to the target. All right, so I consider that as a placeholder for some other technology. And I know some people here know a lot about this and might correct me about that, but that's how I see it. Anyway, okay, enough about the Paris agreements. The other thing I wanted to just mention is that this is all sort of processing information that comes from remote sensing. And I don't know if you realize, but we're in this remote sensing revolution where we have so much data. We get measurements of, let's take the water case, all right? There are satellites that will measure very small changes in the Earth's gravitational field as a function of location on the Earth, and from that infer how much water has either been taken out or put into that particular piece of the Earth. So I would imagine if you looked at this thing called a GRACE satellite, G for gravity, that you could see these sorts of things. And that leads to what I think is a really interesting possibility, which is to think about how this remarkable data set on land use change can actually then layer into other kinds of remote sensing products and measurements that are being done, where we can think about integrating hydrology, water. Okay, if you want to know about climate change and deforestation, of course there's the immediate release of CO2 when you burn the trees. All right, but then you have a different cover on the land. And then you get, from a climate perspective, water balances change at the surface and energy balances change. And the two are related to each other very closely. And it's hard to understand climate change without understanding water dynamics. And so this is one of these many opportunities I think we have to think about how we can merge other observations into this remarkable platform that's been developed to give us new kinds of insights into how we might think about the system. All right. Others, the state of California is going to put up its own satellite. EDF, Environmental Defense Fund, is putting up a satellite only to measure methane emissions. Okay, and all of these platforms that I can imagine thinking about in some creative way, merging them together to tell us a big story about the environment overall. Yeah. So anyway, all right. Well, so my job is to ask a question or two, I think, as well, and I'll stop my lecturing now. I'm wondering. So I think that Tasso already showed that the plan is to cover sort of most of all of the Amazon region, right, and even up into Central America, et cetera. I'm wondering how transferable this entire technology is around the world, right? Indonesia, Southeast Asia, Africa. Is it simply a matter of taking remote sensed information and sort of putting it together? Or are there specific local factors that allow you to do it in Brazil that make it more difficult somewhere else? I'm wondering about that as maybe a first question to start off the discussion.
Cool. Yeah, I think it's in terms of technology itself, like not a big deal. The only limitation for Africa and Southeast Asia is that the continuous collection of Landsat data is, consistently started in 2000, not in 85. In Brazil, it starts in 85 because the Brazilian Spatial Agency put an antenna there and started to collect it. But apart from that, everything else is like more or less the same. There is a lot of problems with clouds in Indonesia, but we have a lot of problems with clouds in the Amazon, so we have to deal with that. So I don't think it's in terms of the technology itself is not a big deal. What is important is to have local groups to do it. So for example, there is the Chinese government had made one map of the entire world of land use on 30-meter resolution for 1 year. They put 10,000 people working to make this manually. But there's tons of problems because the people don't understand what they are mapping, right? So I think for me, it's absolutely crucial to have local groups involved. So not anybody from outside doing, but just helping them to do.
And why are local groups so important if it's really just developing AI to interpret satellite images? I
Because
imagine I could do it.
yeah.
Well, I can't do it, but young people here who know things, right, could actually sit here and do it in principle.
Yeah.
What's the local component? That's what I'm trying to tease out.
Two things. One is because the computer is empty, right? So you have to tell them what is there in samples. So basically the way the algorithm works, we work with random forest is one. There is many of them, but we use random forest. So it's basically you give samples. So you go to one place and say, okay, here, this piece of land, this pixel here, it was a forest in 2017, a forest in 2016, blah, 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 and what something else in another year, etc. So you give the story. So you do this with thousands of points, and then the computer use the satellite information that I have there, feature space there, to create tons of decision trees, and then it choose the best decision tree to find the result. Now, the problem is to know exactly what is there by looking at the image. When you look to the image, like forest, non-forest is very easy. But let's say, for example, forest and palm oil. Then it's like it's more difficult. Landsat is difficult to do it. Like remember, one pixel is 30 by 30 meters. So you can't differentiate anything on this room, for example. Everything in this room will be just one thing, right? So yeah, so what we do is basically if you have people that know the environment, they basically have these ideas because they run a lot there, so they know that this is in this region, this must be soy, for example, because we know it. So the local knowledge is basically.
One other question, then I want to open it up to the group. Okay, so the question is, you've already done a lot of this work, right? Because you have this amazing team that has developed these AI algorithms that, at least for the Brazil context, and maybe the most of South America context, can differentiate pasture land from forest, from other sorts of land cover, okay? I would imagine much of that would be transferable to other parts of the world, but there were a couple of examples I wanted to bring up. One of them is exactly natural forest into palm oil, which of course is a big Southeast Asia. And I'm wondering if, in fact, it's feasible, once you get the training done, can you really distinguish enough differences to identify algorithmically when that happens? Okay, and are there other factors like topography, you already mentioned cloud cover, that would that would require additional local kinds of considerations?
No, basically the local, for me, local is two things. So the first one is this one, that we need local people that they understand the land to know the differences, and first to understand what is important to separate. Like for them, pasture will not be a big issue in Indonesia. So like, who cares about pasture there? But for them specifically, to separate palm oil will be a big thing, right? Or to find out a way to distinguish peatlands from the rest of the forest. So I think that's a very important piece. Is, what you want to map first, and to have the samples. But just to have an optimistic view of this is like, we took us 3 years to do the whole thing, right? For the guys in Chaco, for example, took for them 9 months to do what we are doing, because most of the work, which was like creating the programs, the softwares, and also the algorithms and etc., it's done. It's basically the real work for them is to define what they want to map, make the samples, back again, etc. So yeah, so it's what. But the most important for me is that, because it's not just making a map. We want to make maps and create impact. And so the way to create impact, it's crucial you have local people for 2 reasons. One is buy-in. Like if you say that this map was done by some English guy or something like that, or Americans, gringos that make the map, I mean, we are dead. I mean, nobody will use the map. Now, it's a map done in Brazil with Brazilian scientists and et cetera, et cetera. Even there, the government, they say, we don't know, it's not official. But once they see the quality of the map, they say, well, this is like Brazilian science. Let's do it, right? So I truly believe that have the local people is very important for the buy-in in this sense. The second thing is, if the people are involved on making the maps, they get all the technology and the learning process to actually use this afterwards to create impact. Because they can all the technology that we use here, for example, to create the maps, you can use to actually create tools. For example, a simple one that we are preparing right now for next year is, every time we find one clear deforestation, we look for an image before and after, and we create a simple, it's a 1 page with an image before, an image after, and a design of what has been lost, and a design of the property, and we send this to the public prosecutors and to the environmental agency. So right away they can act without even go to the field. They can just take this as evidence. This is possible because we know how to use the technology by ourselves. So I believe that the best way, we would love to do it, is in Africa, in Indonesia. But the first step is find partners there that wants to engage themselves, I think.
Yeah, that's a great answer.
Okay. When Ignacio Rodriguez was here at Princeton University, he wrote a paper on predicting the water flow in the Missouri, Mississippi River area using fractal geometry. So it occurred to me that you have two dimensions in the maps that you're showing. And the data you're showing occurs over a period which you could say is a rate of change over time. If you took that and were able to do the math to show that for every 100 square meters, so many, over a period of time, so many changes occurred, you could actually build, using the mathematical techniques, an image to show from 1980 or 1970. Incidentally, I was on the Landsat program, that's how I understand it. You could create a motion picture to actually show the change occurring over that period of time. Because the main problem that you have is to change the political will of the leadership to be able to save the Earth. Because satellite imagery gives us the ability to measure the capacity of the Earth to sustain life. So you need to be able to do it in such a dramatic fashion that you show this change over a period of time in images. And that's a challenge for a mathematician and somebody in the motion picture business. So two-dimensional information is not enough.
Yeah.
Because you're covering it, that's all data which is fixed over that period of time. You really want to show the rate of change, because if you show the rate of change, the red flags will go up.
Yeah. So two comments. One is in terms of communication. I think that's great. What we did was like we prepare. We have like you can download GIFs that runs the whole history for each state, each municipality, and so on in 10 seconds. So it's kind of you can see the change and etc. Zoom in, but that's communication. That's different from the data. So there is two groups that are interested in working on exactly this type of idea. One is for water, precisely, because it's a demand from the National Water Agency in Brazil to understand those rates of change. Because if, for example, you see like the one picture, 85 and 2017, is just, it may happen just 2017 was drier than in 1985, right? So there is all this idea of frequency. So it's analysis of the frequency of the pixels in each category over the time. So, and we use a lot this for many others, but it would be incredible if anyone wants to work on this. All data is available. Actually, our main constraint today in the project is that we don't have legs and arms to use the data. So it's why we actually publish the data before we have any paper. So this is not even published yet on any like scientific paper. It's just like everything is out. Our idea is that there will be like tons of people publishing papers and etc. using the data, and that will be much faster than ourselves doing. So we invite anyone that wants to dig into that. Will be perfect.
Guys, the way we will go about to get the most people, talking, and then Tasso can, get some of his breathe and get some water.
Shut up.
So we'll collect bundles of questions. Okay. So we have several people who already, who ask questions, right? But the elephant in the room. You said, ask me about politics. Right?
No.
So we are on the verge. Brazil is on the verge of electing a very conservative, extreme right-wing candidate, Jair Bolsonaro, who already mentioned that he would place the Ministry of the Environment under the Ministry of Agriculture, right? Which is the story that you're telling here. Tell us a little bit.
Can I say just one
Yes.
word more? He wants to promote deforestation. He was very clear that he wants to clear cut the forest. Meaning, it's going to be gone. That's the game. Make no mistake. We are in trouble when we talk about the Amazon forest.
And eliminate the indigenous people too.
Yeah, he's very clear about deforestation. It's needed and should be clear cut. That's main message that's going on. Deforestation is going to be jumped.
Absolutely. So Tasso, so address some like the pressing issues. Given that you produced this evidence and you gave some hints that there was a politics and activism involved here in the way that you could mobilize the public ministry, you could hold accountable, ranchers, large-scale farmers. What's at stake here? Both in terms of the kind of work that you have been doing and the Amazon, and how can the international community somehow participate in some kind of resistance or from the exile, so to speak, right? So we have Vera, and then Vinicius, and then Callis, right, and then Marilia, and then we'll go to the second round. Yes.
And I have a few questions actually, but I'll compress them and you choose whichever you want. The first question is about your comment that you said somewhere in your talk that, and I thought you were recommending this, a move from using the criteria of forest to no forest, from that criteria to the change as a criteria. In other words, not just the presence and absence of forest, but okay, the forest isn't there, but what land cover is there? Is it palm? Is it pasture? Is it cane? And I'm asking you that question because you didn't actually elaborate on the possible implications and uses of what you did for an analysis like that. And to me it seems important because of what Mike was saying, that different plant cover have very different rates of relationships with water and with energy. So it matters a lot what that cover has. So I wanted to ask you about that, and actually it's in reality a question for both of you if you wanted to. The other one, the other question that I have is it possible to do this for the oceans And because I can imagine that there the satellite sensing would have to be, I mean, I'm a historian, I don't know anything about this, but my intuition is that it would have to be chromatic in the sense that you would have to be able to detect, the measurements would have to be chromatic and in temperature, because the issue of the chromatic for the chemical changes temperature somehow. So how would you translate this, in other words, for usage on oceans where, on the surface might be more difficult to tell? And then since you want to talk about politics, I'm going to ask a very naive question, which is that I know that they reduced deforestation, but it certainly didn't end it. And it didn't end it because it didn't fundamentally change class relations or property or undertake a drastic agrarian reform. So I'm asking, Bolsonaro is like nightmare, but is any of this effort to remain within the 1.5 to 2 centigrades even possible under capitalism? I mean, it's a very naive question, I know, but it seems that the property relations that we have and the consequent political regimes that we have would make it impossible.
Carlos, one more, and then you will respond. Yes.
So that's an amazing presentation, thank you. And I'm wondering about the transformation that you initially showed, where you have the reservation in the middle. I'm specifically wondering about the property data. Is that underneath there? Because you have all these tantalizing lines which show property. So is there also data in there that might tell a story about why it is that all of this land was converted to soybean farming? In other words, was it government land that got sold to corporations? Was it already private land that got bought up by corporations or leased out? And then related to that is, what does reservation mean in a Brazilian context, right? This enclosure word gets used in so many contexts throughout the Americas. It means something different in the US than it does in Canada. Is it federal land that can be also developed and leased out for development?
Another one?
1 minute for each. No, we had Vinicius. One more. Go.
Okay,
He worked in the Xingu. Vinicius is an anthropologist working in Xingu.
and well, about a couple of months ago, I was in Belém for the Belém Maestrita conference. I met people here, but there I got to know a little bit of a really amazing project that is being led by Manuela Carneiro da Cunha, who's also part of the IPCC in Brazil, and I mean I just got to know a little bit of it, but she's working with a lot of researchers and people from traditional communities and indigenous reservations to try to make visible what sometimes remote sensory can't get at, but are nevertheless effects of global warming and climate change in general. So they have this really amazing job of talking to getting the people that live in the reservations and like the indigenous people and all of that, and having them participate in the work of the IPCC. So when you were showing us this wonderful data, and I kept thinking, wow, these things would work so well together. And since you were emphasizing the importance of involving local people, I was just thinking of what potentialities can you tell us, or what can you envision about working with the people who actually live in these places, not only in the urban zones, but also in the forest.
Okay.
Big bundle.
See if I can summarize. Vera, forest and forest and change. I mean, what I mean in that moment was to say that what usually we have, and that's global. Like for example, if you take Global Forest Watch, which is an amazing tool, it basically you see trees, known trees. Not even deforestation, because you see trees, known trees, could be like degradation or so on. But that was one approach, and it's because it's very simple to do it on the satellite image, this separation. So what we want to do is to say, we want to have much more. We want to understand dynamics of the land use change, and that was the approach. So I give just one example, like the one for the water, showing the influence. There is several of them. Actually, we just finished 7 documentaries of 5 minutes each one, which is telling stories about how the people are using the data and how this is important. So I would just say one of them in 15 seconds. Fundação Oswaldo Cruz, which deals with tropical diseases in Brazil. We have recently this yellow fever coming back. So what they're doing is they take all this data and they're trying to understand what's the potential relationship of the yellow fever spread with the land use change. Is it possible that where you have less forests, you have less monkeys, and then you have less indicators of the mosquitoes, and then you have more people? And they are using this to define where are the lands that they have to have more vaccination, because you can't vaccinate all the population, because otherwise you have resistance to the. So you have to be very precise. So that's just one application, and there is tons of them that we never even think about, and they're just popping up the different applications. That's what I mean by having this large scale. Oceans, yes, we always get these questions, and there is several groups trying to think about the ways to work with satellite imagery for oceans. The main problem for the oceans in general is it's very simple. It's before you use the image, you have to be sure that the image is in the right place. And the way they do to kind of guarantee that every time you have an image, it's in exactly the same place, that you use points on the ground, fixed points on the ground, and they say, okay, this point.
On the ocean floor.
I mean, in the land is very easy, right? Now in the ocean, it's very difficult to find points that, to anchor the image. So it's very difficult to guarantee that what you're seeing is the same place. Like every single pixel there, and that's something that Google did for us. Like normally if you use satellite images, you spend like months just adjusting the image of 1 year, another year to be in the right place. People that work on remote sensing know that. Everything of that is done pre-processed by Google. So when you use the Landsat imager in Google, it's all correlated. The same pixel will be always in the same place forever, and that's much easier to work. So the big challenge is this one. Now for temperature, tons of satellites, Landsat has a temperature band, so you can see temperature. Chromatic is all we see there, so it's that's not a big issue. I think the big issue is this thing, and the other thing is what we call multispectral satellites, which is a new era of satellites. Those satellites that we use have 7 bands, which means like they take 7 parts of the spectrum, right, of the light, and then of the radiation, right, and then you have satellites now that will run 400 bands, so you can see things that your eyes don't understand, and then you. Yeah.
I'll just add a comment about oceans, which is that the way that typically we estimate how much this natural land sink is taking up in terms of carbon dioxide is just by knowing how much is going into the atmosphere, believing that we know how much the ocean is taking up, and then whatever's left must be going on land because there's no other place for it to go. All right, so that's usually the way the estimate is done. And it turns out that recent work, including some done here, indicates that we may not really understand the oceans as well as we think we do, especially the Southern Ocean, where there's a lot of dynamics going on, so that the numbers on the land sink and the ocean may change a little bit. It's also the case that oceans, of course, you've got this 3-dimensional, depth to it, and everything is moving all the time. Yeah. And it turns out that there are other things that you can measure, just atmospheric concentrations of different components, and that can tell you with pretty good accuracy things like the overall amount of heat that's being stored in the ocean. And if you don't know, when we're emitting greenhouse gases into the atmosphere, and more than 90% of the heat that gets trapped winds up in the oceans. Mm-hmm. So the oceans are really important to understand the entire sort of planetary dynamics. So it's an important question that you raised about how much can we understand the oceans, and because it's really fundamental to a lot of things.
Yeah, but saying that, one of the things that is being done today is like tracking plastics using satellites.
Yeah, well, of course, right.
So
Those float.
Yeah.
But ocean pollution, of course, is
yeah.
a whole other topic, which is another
yeah.
disaster. Yeah.
So it's possible to get zero deforestation. I think translating your question is like it's possible to get zero deforestation. That would be the question that we always make. I would say like 20 years ago that was a kind of a dream, like you just have as a dream. And today I think it's something that it's feasible and possible. It's just the question is how fast we will do it. And that's feasible and possible for mainly three reasons. One is the society in Brazil, and I would say globally, it's turning to something globally, don't accept any more deforestation. So the idea that deforestation is something bad, that is harming in general us, and because it affects our rain and stuff like that, that's something that was built on the last 20 years very strongly on the mind of the people, even in conscience. Like if you talk about, and you ask any Brazilian, what's the main environmental problem? Deforestation. It's just because it's there. So I think that's one thing. The second thing is business get involved. So you have tons of commitments, arrangements. There is the Consumer Goods Forum and others, other agencies. It's basically going from the supermarket to, Burger King or Burger King, I think but McDonald's or something. Some of those, unfortunately, Burger King, which is Brazilian. I don't have the commitment yet. So these guys are basically saying we will take it out deforestation from our entire business. And so this thing is moving a lot of agreements and different arrangements to work with that. That's the second. And the third one is that there is a lot of alliances now being built. And I would just mention one. In Brazil, we have something that we call the Coalition of Climate, Forest, and Agriculture. Climate, Forest, and Agriculture, which is basically, most of the most important business organizations in agriculture and fertilizers and stuff like that, with the NGOs, the different NGOs, and then basically have a common agenda on climate. And this common agenda on climate includes, as a vision, what we call finished deforestation. As a strategy to deal with climate, and because climate is very important for agriculture, blah, 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 blah. So the whole thing. So I think that the mentality, the mood to do it, it's there. The tools to arrange that, it's there. So now it's just a question of having, if we can navigate on the, on all the political pressures and so on. So even if we have Bolsonaro, and for the next 4 or 5 years, we'll have a very, difficult time and etc. It's just a question of time. If it's not in the next 4 years, it will go afterwards, and we will get it. I mean, it's considered done. By 2030, we will have there. We will have to be there. So I mean, zero deforestation, at least zero net deforestation, because we still have some minor things happen here and there, etc. Property data. That's a cool one. That's the first time you will see the property data in public. It's actually, there is a register that was created by a law 4 years ago, 2012. So every single property in Brazil, they have to register themselves. It's a self-declaration. You go there, register the land that you say that it's the land that you are managing. And then, so this is being built for the last 5 years. December now we'll finish the era of registering. And this is linked to many things. So for example, if you're not registered, you can't get credit on the banks and things. So there is a lot of links, which is basically, it's a self-declaration, but you have to declare otherwise. And if you declare something false, it's like income tax. So it's your declaration. So if you declare something false, it's your problem. But the most interesting part is that since you declare that you are taking care of this piece of land, if I find a deforestation there, I don't have to ask who is responsible, because you said that you are responsible for the piece of land. So I just say, oh, that's you. No, that's not me. No, it's you, because you design here, decide that you are responsible. So I don't care if you have the land title or not at this moment, but I do care that you said that you were responsible for this land. And so let's talk about it. And even if you have a lot of, I show a piece of the map that is like beautiful, because there are parts of the map that was like 7 people said that they are responsible for the land. So there is this whole mess there. And then our approach to this is say, okay, there is 7 people in this area that was clear cut. Send the penalty to all the 7. We will very quickly know who is actually the one that's managing there, right? Because I have to correct. So that's the process. So it don't say anything about land property. It actually say about land tenure by self-declaration. So obviously, if you declare land inside of indigenous reserve, it will be canceled and stuff like that. this whole process will take years until we clean up the whole thing. But it's incredible because you have, one map with 4 million properties available. So what we did was like we collect all this information, prepare a database, and make it public. And the big debate now in Brazil is whether you can put the names of the people there. For example, politicians. If you know the politicians that have the lines. So we have the code, but we still don't have the social security number or the name of the person yet. But eventually, one day, we'll get this. So what is a reservation? Reservation, I mean, I call it reservation because this one is a reservation, but it's the protected areas in general. So Brazil will have like basically 2 big categories of protected areas, the national parks and stuff like that. And then the indigenous reserves and other types of community land, titling, etc. But by definition, the protected areas, most of the protected areas, with the exception of one category, is public land, and most of the community land, all the indigenous land is public land, and except I think quilombolas, right? I think the Afro-Brazilians lands,
Afro-Brazilian
they can get the
slaves.
title, but all the others is public land. So it's managed. You can sell the land. Public land is 300 million hectares in Brazil. So it's about 60% of the forests in Brazil are in public lands.
60%.
Yeah, 60 to 70. Have to figure out. So, and considering that a lot of the declarations of land in the Amazon, it's like people are making it bigger than it should, because you have to have a minimum area of forest in your land. So, if you have an area here that you clear cut with 100 hectares, when you put on a map, you say, I need another 500 to be legal. So you design like 500 on the forest, and then to have. But this will be cleaned up on the future, because there will be one piece over the other, and there will be all this process for cleanup for public land. But it's part of the process. Local with local people and applications. On the films that we did, there was 2 interesting ones. One is in Xingu, actually, where there was 4 of the groups there. I don't remember all the names now, but I think it's Chicrins and use. Well, I'm not trying, but because this is a big piece of land. So what they are doing is that they use these maps in the reserve to track what's going on the borders, especially in the south borders, because they have this program for restoration where they collect the seeds and they provide the seeds for the farmers to make the restoration along the area with ISA and the Instituto Socioambiental.
Restoration of the
forest.
land.
Yeah. So the idea is to restore the lands that are in the border and also along the rivers, because the farmers are finding out that they have less water now. Clearly, they can measure that. The temperature is 3 degrees up of the average in the Xingu area on the right side of the park because of the lack of trees. The whole thing about the whole balance, etc. So it's a big thing. So there is all this debate on how to do. So they are monitoring what's going on the borders at the same time that they are engaging with the farmers through local NGOs to kind of recover some of the forests and so on. So it's kind of cool. So, but there is tons of applications possible. Right?
Let's collect a second round. Okay. So we had Marilia, and then your name?
Chris Crawford.
Chris. Then we have Beto, and your name? Mark and Adriana. Okay. Condensation, so we can get, the most out of Tasso.
And now I'll give answers of 30 seconds.
Okay. So I'm very happy to hear about your optimism in relation to 0% of deforestation in Brazil. I hope you're right. And but my question is in relation to the whole processes of mining and hydroelectrics, buildings, all these projects of occupation of the Amazon. And so how can we think about zero deforestation with all these other pressures and against indigenous people, etc. So how you balance your point in these regards. And in relation to the Paris Agreement, is there anything possible to plan like the Amazonian Agreement in the next years, an international movement to help us not destroy it?
Hey, Chris, thank you.
Yeah, thank you for the talk. This is fantastic. I'm a grad student in the environmental policy program. I just had a quick couple questions. The first one is just about, so Landsat is great because we have a time series of satellite images, but recently we've got really, really, really high resolution data, and I'm curious, sometimes less than a meter in resolution, and I was curious how your project is planning on integrating that type of high resolution satellite data, how that might actually help solve some of these classification problems that have been so challenging, and sort of the vision that you see in the future for how this is going to, in terms of the technology and the computing power that's required to deal with these things. If we'll get to a point in the next couple of years where a global land use map at the 1 meter level is feasible. So that's the first question about high resolution data. The second question is about terrain, and particularly mapping in really steep mountainous regions and the challenges that those types of regions face, and how you dealt with that and how that might change how transferable your work is to other regions particularly.
Beto?
I think the questions of zero deforestation, for me, on the long run, I agree with you, but I think you have to remember about the tipping point. In 5-7 years, we can actually reach the tipping point, and the end of deforestation, it's gone, because even we agree on that. So I'm not so optimistic, although it's possible.
So Brazil has the Código Florestal, the forest code, which says that if you buy a rural property anywhere in the country, you need to reserve at least 20% of the property as forest, plus any areas around streams or rivers and mountainsides. And that's different from here in the United States. I can buy a property in Iowa, and I can plant corn or wheat from border to border with no limitations. So that's a really interesting thing, and it seems to me that this system could be used to monitor compliance with the forest code. And we know that in terms of biodiversity, if you have 20% of the land preserved, that will make a tremendous difference in terms of biodiversity. So the difference between zero forest and even 20% forest is quite significant. One other quick comment, Brazil is different from perhaps any other country in the world in that you have millions of hectares of degraded pasture land, which can be brought into agricultural production without deforestation. And it seems to me that if you show kind of before and after photos or images, and you see large increases in agricultural land, that some of that land is actually not negative. If some of that land replaces degraded pasture land, that's not a negative thing.
Mm-hmm.
Adriana?
Can you talk about the political effectiveness of the maps? Because it seems like when you got the evidence of deforestation in real time, that the data became politically effective. So I'm interested in kind of the interfacing with the judiciary in Brazil in terms of bringing political effectiveness to the maps, and also how can the Brazilian experience inform the political work that needs to be done around these maps elsewhere as it moves to other places in the world?
30 seconds for each.
But
But the
each question,
conversation-
not each person, right?
Yeah, each question. But the conversation will continue the next few days. We are just getting started here.
So let's see. Infrastructure. So the way, so I would just tease here, because then you can discuss after. If you go to here, this will be online completely in the by Friday. So basically, you can go to all the infrastructure of transport and energy in Brazil, everything. So for example, if you wanna, let's see if I can do something very quickly here. If you go to, for example, roads, let's see if it works because it's like a, but basically you will be able to click on roads, then you have all the federal roads or the state roads, and then you can analyze a buffer over this area. So you can go, let's say here, command, oops, here. So let's say I go infrastructure. Let's do some other, which will be quicker. So let's say go to hydroelétricas, right? So say generation, and I would take the hydropower. So here's all the hydropowers in Brazil. And then if I select here a buffer, let's say 20 kilometers. So it now you have like 20 kilometers, right? So you can see what's going on around those areas, and then you can generate all the statistics on the fly for the history in this area. So you can have, by each infrastructure in Brazil, what's the story, what's the impact, and then you can play. So because this is like so giant in potential things to do, we will launch in end of October a prize for studies that relates infrastructure and land use change using the platform. So it's basically open to anybody, and that just to stimulate people to use this. This will be like all the solar panels, all the wind power, all the thermal power plants, everything is there. The whole thing is there, and with date, so you know when it starts, and all the story of the land use will be available. So the idea is to, really talk about infrastructure because it's absolutely crucial. And but you see, like the direct deforestation by infrastructure is very small. What happens is that it creates conditions, because you have many people, to actually have other transformations happening. But it's other economic activities that are attracted to that. So if you can control the other economic activities somehow, then even if you have the infrastructure, you will have like the proper control. And this is related to the question of the pasture. And then I can show you some other interesting things here. This is an invitation for you to play, right? Mapbiomas.org, don't forget. So this is São Paulo State, right? So what you're seeing here, São Paulo, not much forest there in São Paulo, right? So it's just like the coastal zone, which is like the Atlantic rainforest. Everything that's yellow here, that's in 85, that's all pasture. And everything you see like in this pink here, it's agriculture. Most of that in São Paulo is sugarcane, right? Biofuels. That's what we have here. Now that is 85, right? And then 2000. And then it's growing, right? The sugarcane is growing. And then you have 2017, and boom, there's tons of sugarcane there. So you can see that on the data here. Very quickly, I will just put here on this map forests, agriculture, and pasture. All data is there for you to play. What you see there, that all the sugarcane is growing in São Paulo. While the sugarcane was growing, the pasture was going down, and the agriculture and the forest actually is growing a little bit because there is a lot of restoration and reforestation also happened there. So basically, there is a way in which you can see agriculture growing, pasture going down, pasture land going down. But the most interesting, because we don't have yet the data here to show, but is that the number of animals that we have, the cows that we have in São Paulo, is the same. It didn't drop. And the production and the value of the production, it's growing. So it's basically intensification that's happening. No? So I truly believe that this kind of process that can happen, all over the country, but with one difference. There is this question of the chicken and egg, right? So there is this question. You have to increase productivity in order to decrease deforestation, or you have to stop deforestation to force the increase of productivity. And what São Paulo shows is that these two things should happen at the same time. So you have a lot of restriction to do anything on Atlantic rainforest. There is a law on the Atlantic rainforest which basically prohibited any kind of conversion. And at the same time, you have a very steep increase in productivity on this side to actually be able to compete with the price of land for agriculture. So you can see this happening. So I think the two things should happen at the same time. Almost 30 seconds, right? Amazing in terms of time today. So that high resolution 1 meter, yes. There is another project that we call, like, just remember these words, next gen map. So it's a next generation map. It's a project with Moore Foundation, Planet Labs, Google, and Biomas. So what we're doing is that we're taking this constellation of, the Planet has this constellation of 180 satellites. It's like this size, the satellite. And it basically runs and takes pictures of the planet every single day, everywhere in the planet, in 3 meter resolution. So it's just 4 bands, it's not 7 bands, it's like it's more poor the image, but it's 3 meter resolution for the entire planet every single day. The problem is it's too much information to process. Like the information is coming down and we are trying to process it, capture all that. So what we are building up on the last year is like making a flow of work of how you do in large scale for the country, having all this information flowing in, putting this in Google Earth Engine, process them, etc. So we are, by December, we'll be presenting the workflow and the whole methodology for that. So that now we know that it's possible actually to process this in large scale. In 1 year, 2 years, this will be like really feasible in large scale. But it's interesting. With 1 meter resolution or 3 meter resolution, 1 pixel is 1 tree. Looks fine, right? Now, if you have a tree in a pasture, just 1 tree, it will classify as a forest, right? So it's kind of, it's a totally different idea. It's not like you take each pixel and start to classify each pixel. It will not be like that. It will be a totally different way of viewing the thing in which you have to orient your thought to an object, finding things. So the exercise we're doing tons of exercise with our teams, for example, finding irrigation pivot. Yeah, when you have irrigation like goes round and make these rounds, you know, like pivot irrigation. Yeah. So we prepare a deep learning algorithm that use another stuff. It's like TensorFlow and all these complicated things that it's even for me for this explain is difficult. But basically, it's a machine that is trained to find out where are those damn people all over Brazil. So once you train this machine, and they are very good on doing that, like using the same algorithms that make this this computer wins the Go game. Have this thing, Google have this computer that wins the champion of Go game. Go is a Chinese, I don't know, very complicated. And so we use the same platform and algorithms to train them to find those pivots and many other objects. So ideally, in 2-3 years, you will be able to run every week a machine that runs over the country, over the planet imagery, and find out where are all the pivots for irrigation every week. And you could have this every week. I'm not talking about anything like, it will be like 2-3 years, that will be like totally common to have. So imagine you can have this for many things. So you could have eventually many objects. So our vision in Next-Gen Map is that in 10 years, the normal would be to have a picture of the world every week or every month showing the land use and the land use change. Which is a very it's a very different approach because, for example, you have a land that was planted, and then next week it's harvest. So you say this is agriculture, and next week is not agriculture anymore. So this difference of what is cover, what is use, what is management practice will come to light. There is tons of things that you can do. The most important, and it's something that I learned with Beto many years ago, and he always kept putting me on the head, is like, all of that is beautiful and incredible in terms of technology and said. The thing is, how you don't get fascinated with that, and don't forget to how we use this to actually create impact. And so all of that can give you like all this marvel thing, but the important is what I can get for each one of those steps that will turn into an impact directly. And that comes to the point that, that you ask about the judiciary. So we are working closely now. We have this, after we finish those maps, we are creating what we call Map Biomas 2.0 as the next phase, in which instead of preparing just annual maps, now we will prepare monthly maps of deforestation, degradation, and logging. And the way we are doing this in a different way of what's done today is to use high-resolution imagery to produce proof facts. I don't know if you can say that. Produce documents that can be used by the judiciary as proof without having to go into the field. So then you can have, like, today, when you find a deforestation, Ibama have, like, you send the information, they have to go to the field, check, guarantee that it's there, and then, so it's nothing. And we are talking about, last year we had 90,000 alerts of deforestation. 90,000. So how much of them receive any penalty or something like that? Probably 1,000 or something. So last year, an exercise that was done by, I can say that, Amazon started, but you never see Amazon publicly on this, because it's like part of the strategy, but let's say, Amazon started this, was basically, they started to do this using Landsat imagery, but basically take the information, picture before, picture after, etc., and prepare those to the public prosecutors, and they put out in one day 1,200 actions.
About $300 billion. Actually now it's $3 billion fine against those guys.
And we are learning about this process now because we're starting to see the first responses from the judges. And many of them are just returning the thing, so we are learning that they don't understand what we are preparing. The judges don't understand. So there's a new process now which is kind of, okay, let's talk with the guys that take the decision to find out what they want to see to be sure to give the gain of cause on something that is illegal, right? Some of them is like maybe just a problem with the judge, but the thing that most of that is that people don't understand what they are seeing at the end. So we really, that's really absolutely cool. The problem we have, and it's a problem, it's something that is always a question, is whether what we produce is official or something like that. So our argument now with the judiciary, and the Ministério Público like that, so they say for us it's normal, is that when the public prosecutors, they need some, or the judge, they need some kind of a technical opinion, what they do? They hire someone, right? A consultant. So what's the difference of hiring a consultant to do it or having someone that provide this for free, available to everyone, open in the internet and visible? So we have to build up the argument but as a whole, not an argument case by case, but build an argument that says, okay, anything that works like this will be, could be used by any judge in country. So that's similar to something we did some years ago, where it was like link the responsibility of the deforestation to anyone that buys a product that comes from that area. So the way we create the case was using those cases for cars. When you buy a car, if the car was stolen from someone else and you just buy the car, you can buy in good faith, right? You didn't know, you just bought the car, and then suddenly you realize that this wasn't a stolen car. You may not be prosecuted, or you may not be, in prison or something, but for sure you will not get the car, right? You lose the car. At least you lose the car. So we start to use that with the farms that have illegal deforestation, saying, if the deforestation was illegal, the animals that are in this area is illegal. So then nobody can buy this thing. It's illegal. You cannot preempt this thing, etc. And actually did some operations, like crazy operations, like collecting calls, totally crazy. But it's kind of this type of exercise I think we have to do now that we have this type of mechanism, just trying to connect.
So why don't we pause here? And we want to thank Mike, Celia for being here, for your support. And we want to thank Tasso for an incredible visionary